There was a way that I paused. Okay. So, first, again, it's not asking for it, but what type of test is this?
Goodness of fit.
Chi-square goodness of fit. Good. Chi-square test. Well, that's square. It's very poorly written. Chi-square goodness of fit. Now, again, let's say you're like totally stumped and you just don't recognize what type of problem it is at all. Take a look at what type of questions I'm asking of you. Look at this table down here. In this table, I'm going to want you to fill in, I want you to fill in the observed, the expected, and the contributions. This table will only appear for a chi-square goodness of fit problem. Okay? So it's kind of like a little hint also, like the questions itself. Okay, so what are the null and alternative hypotheses? So recall, when it comes to the null, it's going to be one of two things. Either all of the proportions are, you're told in the problem that they're all equal, so then you have to divide 1 or 100% by how many there are, like the last example we did in class today, when we said there was 4 different color of beads. And we're like, okay, so 100 divided by 4 is 25, 25% each, or 0.25. In this case, though, it's not telling us that each letter grade is the same percentage. Instead, it's telling us exactly each percentage. A's is 25, B's is 25, C's is 40. So that is the population proportions that we're starting with. So P sub 1 is 0.25. P sub 2 is 0.25. That's the B's. P sub 3, the C's, is 0.40. P sub 4, the D's, is 0.05. And P sub 5, the F's, is also 0.05. Because all of those percentages were given to us.
I put for P1 and the rest I put 42, 36, and so on.
Oh, so remember, these P's are proportions. Mm-hmm. So they're always going to come from a percentage. These aren't percentages. This is like the actual number of how many people got A's. 42 people got A's. Not 42% got A's. 42 people got A's. So this is actually going to be your observed values. This here is your proportions.
It has to equal 100%. Right?
And yes, also, and good point. Remember, these have to add up to 100%, or they have to add up to 1. So if you did at first accidentally do these numbers, you'd be like, oh crap, that doesn't add up to 100%. This doesn't, or if you're using decimals, this doesn't add up to 1. So that'd be an indicator to you like, oh no, I'm not using those numbers. There's different numbers.
Wait, so how did you get the P1, P2? How did you get those numbers?
So they are given here. We're given that the A's are 25%, B's 25%, C's 40%, and so on. And I just converted them to decimals. And then again, add these all up. It should add up to 1. Okay.
If you guys don't have your formula sheets yet, I would suggest to really look at that. Because it makes things a lot, less, stressful. I think.
Yes, always use those.
Is that the same one that we used for the last test?
It should be
Every exam has
that
different
one. Yeah.
This one?
Both. You can use
Or-
one or both either.
And those are on the modules?
Yeah.
Mhm. They're similar. They're just slightly different.
Excuse me.
Okay. So then for the alternative, we could say the grade distribution is not all correct. All right, that grade distribution that they gave us, and we just rewrote there, we're saying they're not all correct.
Can I also put not all final grades are the same? Or does that mean?
No, you don't want to say that not all final grades are the same, because we're not saying they're the same. We're saying they're these percentages here.
Okay.
Okay. If instead the problem had said Let's pretend for a second it didn't give us this breakdown here. If it said that the grade distributions were all equal, then that would be A, B, C, D, F. That'd be 5 options, right? 100% divided by 5 is 20%. So you would say that P1, P2, P3, P4, P5, they're all equal 20%. And then in which case, then you could say they're not all the same. But we're not, nowhere are we starting by saying they're the same. Okay, next, find the expected frequencies. I want to pretend, let's just pretend that this is even here. I put this in here because I thought it would be helpful, but I found that actually more students get confused by it being here. Because I think, yeah, so let's just not even do that, okay? But we do need to fill in the next table. Complete the table below to calculate the test statistic. So one thing at a time, let's do one column at a time. The observed, where do I get the observed values from?
The
Top.
P.
Where the A, B, and C are.
Yeah, from this table right here, right? This is what we observed to be the actual number of grades received out of the 160 students. This is the observed. The observed values will always be given. So then you just need to copy them and bring them down accordingly. So we were told there were 42 A's, 36 B's, 60 C's, 14 D's, and 8 F's. Okay. Next is the expected values. The expected values does require a calculation on your part. In order to calculate it, you have to take N and multiply it by its corresponding P. Take N and multiply it by its corresponding P. So what is N?
160 students.
160, good. And then the P is depending upon what letter you're at. So remember, P is all these guys up here. They're not all the same though, right? So it's going to be your P for A is 0.25. P for B is 0.25. P for C is 0.40, and so on. So let's do it out. Oops. Okay, so for the A's, 160 times P. The P for A, we said, is 0.25. Doing that math will give you 40. Similarly for B, N is still 160. The proportion for B was also 0.25. So again, you get 40. For C, N times P, the sample size is 160. The proportions we said for C was 40% or 0.40. So that will give you 64. For D, sample size 160 times its proportion. D had a 5%, so 0.05, which will give you 8. And then lastly for F, 160 times 0.05 again, which is again 8. So any questions on the expected column?
Back to C again, please, Professor. What happened again there? I guess I did something wrong.
So for
I calculated
C,
4, but I think I calculated properly.
so for C, we're taking the sample size times its probability or proportion. So 160 is the sample size.
Yes.
Times, we were given that C's was 40%. So 160 times 0.40 is 64.
Correct. Thank you.
Mm-hmm. Okay. Lastly, we need to calculate each contribution. All right, calculate each contribution, which the formula is given here to help remind you how to do so. Recall, you're going to take the observed minus the expected, quantity squared, all over expected, where you have your observed and you have your expected. So you have to substitute it in for each. Okay, so we don't really have a whole lot of space here, so I'm just going to do it down here. So for the A's, The observed was 42 minus the expected, which was 40, quantity squared, all over the expected, which was, again, 40. Feel free to plug that into your calculators. I could do it here. I'm not going to do it for all of them, but I'll do it for one of them. Sorry, guys. I think I'm getting like a phone call on my computer. I don't know who that is. Okay, so I'll let it go to voicemail. Okay, so on top we have 42 minus 40 quantity squared all over 40. And you get 0.1. Okay. 0.1, which I'm going to put there. Okay. And repeat. For B, take the observed 36 minus the expected 40, quantity squared, all over the expected 40. Once you do that, you should get 0.4. So 0.4. For C, again, you're just repeating this over and over again. The observed was 60 minus the expected 64, quantity squared, all over 64. You should get 0.25. For D, the observed was 14 minus the expected 8, quantity squared, all over 8. That'll give you 4.5. And lastly, for the F's, that is 8 minus 8, quantity squared, all over 8. And that will actually give you 0.
Professor, I got, starting from C, I got 144. And then with D, I got 2,380.
Let me take a look at your calculator. Something's not right there. Oh, this it's not 160, it's the observed value. The observed, let's do the bottom one. The observed is 8. Right? Minus the expected 8, all over 8. You were entering in the sample
Yeah.
size.
Okay, thank you. No wonder I was getting whole numbers out.
You're like, what's going on here? So that was just some side scratch work. Any questions on filling in the table?
So remember D, so it'll be 14 minus the
14 minus 8, quantity squared,
over 8.
all over 8.
Okay, I see that. Let's go like it. Okay. Thank you.
Uh-huh. Okay, so then how do we calculate the chi-squared test statistic?
You add your totals?
Yep, you add this last column. You're adding together all the contributions. So you take 0.1 plus 0.4 plus 0.25 plus 4.5 plus 0. And so you'll get chi-squared to equal, you should get 5.25.
And 0. No, it's 4.5. I got 4.5.
Any questions?
Thank you for that.
Okay. So let's continue. The degrees of freedom. So to calculate the degrees of freedom for this problem, you do k minus 1. Remember, k is the number of possible outcomes. How many possible outcomes did we have here?
Uh,
3.
More than 3. We had 5.
Okay, 5.
All right, 5, because you could get a letter grade of A, B, C, D, or
I
F.
always got that.
6, 4.
Yeah, we'll just,
4.
Say again?
we don't have that.
yeah, we don't have.
You don't have this page? Oh.
No,
It's
it's
behind 3. It's double-sided.
We just take out a sheet of
No?
So this isn't part of 3?
Oh, maybe.
Oh, no,
Is it-
no, because,
Is it on the back of number 3?
Oh, yeah, it is, yeah.
Oh, okay. Yeah, it's on the back side of number 3.
4. 4. 4.
Yes, which is 4. Yeah, so you take your degrees of freedom, which in this case, or so you take your number of possible outcomes, which in this case is 5, because there's 5 letters, A, B, C, D, or F, and then subtract 1. All right, then let's find the p-value. So the p-value equals chi squared CDF. Your lower bound is your test statistic, which we found to be 5.25. It's always going to be a right-tailed test for these, so going towards positive infinity. And then the degrees of freedom, 4. Please practice this in your calculators. I know I didn't say where to round, so let's round to 3 decimal places. Make sure you're able to get 0.263. If you're not getting that, raise your hand. Then we could make our conclusions. Or does anyone need help getting that p-value?
Rounding off to 3 or 2? Or
3 decimal places.
Okay, 0.263.
Correct, yes.
Miracles happen sometimes, I guess. They really do.
All right, so our p-value, let's convert that decimal to a percent. That's the same thing as 26.3%. Is that less than our level of significance of 1%? No, it is not. Therefore, it is not statistically significant.
Not.
Therefore, we do not reject the null. And we do not support the alternative. Lastly, let's state our conclusion in the context of the problem. So, at the 1% significance level, the sample data do not support the claim that the grade distribution what did we say? The grade distribution is not all correct. Yes.
Can I see, back to page 2 at the bottom, underneath the, yeah, that. Thank you.
Mm-hmm. All right, guys, we've done 2 of the 4 types. Let's keep going. Number 3. Suppose that each person in a random sample of 48 male students and in a random sample of 91 female students at a particular college was classified according to gender and whether they usually or rarely eat 3 meals a day. The data from the samples were organized below. So we're broken up by male and female, and whether they usually eat 3 meals a day or rarely eat 3 meals a day. At a 5% level significance, test the claim that the distribution of population proportions for gender is not the same for each response. Again, I'm going to give you guys a 5-minute head start. Okay, so what are the, well, first of all, it's not asking for it, but what type of problem is this?
Chi-square for homogeneity.
Yep, chi-square for homogeneity. Homogeneity. So hard to say. 2 ways you could tell that. The question is whether or not the population proportions is the same for each response or not. Another way you could tell, again, looking at the question, what's being asked of you. It has an expected values table here, so that's an indicator to you that it's either a chi-square for independence or chi-square for homogeneity. And it's definitely not an independence question, so homogeneity.
Professor, would that kind of different, it's like an analogy, would that fall in the category of a type 2 error, maybe, possibly?
So the type 1 and type 2 error doesn't have to do with the type of test. It has to do with your conclusions, whether or not you reject the null.
Oh.
Exactly.
Now, I was thinking of as far as analogy, as far as the, it's not clear, so it'll be a type 2, let's think of that level, no?
No, so the type 1 and type 2 is only based on whether or not you reject the null. If you reject the null,
Okay,
type 1. If you do not reject the null, type 2.
okay,
So,
thank you.
for the chi-square of homogeneity, or however you
Mhm.
say it, so I can't really like decide if it was chi-square for independence or this one. But it says multiple populations, so does that mean more than 3 or 2?
2 or more.
2 or more?
Correct.
Okay.
2 or more populations.
So, if you're trying to identify what type it is, right?
Yeah.
Something that's pretty telltale for homogeneity is that the population proportions is not the same for each response.
Okay.
Does that make sense?
Oh, okay, sorry. Okay, yes, thanks.
All right.
Thank you.
All right, so let's go over the null and alternative. So for the null, the distribution of responses. Oops, I missed a word. The distribution of responses is the same for each gender. And then the alternative is that the distribution of responses being, eat 3 meals a day or never eats 3 meals a day, is what?
Is not the same?
Is not the same. Good. Is not the same.
Well, I had put population proportion, is that okay or no?
So population proportion is more just in general, like the general layout of it, but then I want it in the context of the problem. So in this case, the context of the problem, the populations is broken up by the gender, the male and female.
I put gender, but I just didn't put response, I just put population proportion for each gender is
the same and the left.
Oh, okay. No, I want to see what the problem is referring to. And so in this case, it's their responses to that survey. Yeah. Good question. Okay. Fill in the expected frequencies table, and then are the criteria met? So we know to do this, we need our matrix, right? Need our matrix. So I'm going to take this data that's given to us and enter it into matrix A. So second matrix, edit. How many rows and how many columns?
2.
2 by 2. Good. 2 rows by 2 columns. Enter in your data. It's not even giving a total column or row here, but if it did, you would not include it. Then you do stat, test, go down to chi-squared test. Observed is A, expected is B. And again, it was a good point that one of you guys made that at this point, we're given chi-squared. You're given the p-value. You're given the degrees of freedom. If you want to jump ahead to that part and fill in those pieces, by all means do so. And then if you want to go back to fill in the expected values, that's A-okay. I'm going to go and find the expected values by going back into my matrix, going over to edit, and go to matrix B, because that's where the calculator entered the expected values. Again, it's ugly on my calculator because of the app, but on yours it should be nice. You should be able to see at least 3 decimal places. So I'm going to take those values and enter it in.
I gotta change it over to 2. That should be 2 still, right? 2 by 2 though.
Correct, 2 by 2.
Yeah, I gotta get that over there.
So 26.245, 21.755. Everyone should be trying this, making sure you're getting the same values. If not, let me and Kristen know so we could come help you out.
Let me get that's over 2 by 2. A's in 2 by 2, but my B's not in 2 by 2.
Okay, so that's, we'll do that later. Just get, oh, you're in the list,
No.
hang on.
I was in
Yes, sir, I got totally
Yeah, it's a
different
matrix.
numbers.
yeah,
Okay.
2 by 2. So
that's for my
So we're gonna do stat.
I got this.
Gonna go.
So if I go to matrix, and
Or either
A, so A
go to
is
that.
20, so just double check.
Go to that.
26, 54,
Go to that.
57.
I'm going to matrix. I'm trying to get this over
And
here.
then go
Yeah,
back.
you have to put in the values
go back.
first and then go to,
The value that I did, if I
Go to the
it's
okay,
already there.
so then we're gonna go
A,
to
B,
stat,
calculate,
test.
second matrix,
I was
Squared,
getting like
right?
64 point something.
Yeah,
And
maybe
then
I
we
don't know
can
why.
go
Did you go to
back
matrix
to
C on
second
accident?
matrix and it'll be
No,
in 2 by
it was
2
matrix.
automatically.
Yeah,
I see, okay,
And I
I see.
don't know why
Got
that
it?
was
Thank you.
confused.
So I do
Did you
get
do the
this.
test?
You run the test
chi-square
first and then
So
it'll
it has to
automatically
be
change.
You have to do that
Okay,
first.
that's what it is.
You can't
Take
just
the
go
test
straight to
and then go
matrix
back.
B, you have to
Don't
do
worry,
a
I'll
chi-square
do
test
it.
first. Because without that, your calculator
This
doesn't
is
know
the
to
best one.
update your expected values.
Oh,
This
so
is
that's
this is
why.
in here.
Yeah.
Okay, thank you.
Did you still have a question?
No.
Okay. Good questions.
The first 2 numbers are for the males then, right? The first 2 numbers are for the males, I guess.
The
Males.
top row.
Top row.
top
Yeah.
one's males.
Yeah, I'm sorry. Not the same. Rounding to 3 decimals, okay, 26.245. Makes sense?
Yep.
Okay. 0.756.
Okay, so are the criteria for the chi-square distribution met?
Yes.
Yes, why?
They're greater than 5.
Yeah, so you want to be explicitly clear for the exam. Each expected value is greater than 5. Then what is the test statistic, degrees of freedom, p-value? Again, that is all from our calculator. We had already found that here. I'm just gonna round them to 3 decimal places. So the chi-square test statistic, I got 2.314. Degrees of freedom is 1. And the p-value was 0.128. Yeah?
When I was doing the p-value, 0.128 stayed the same, then the last numbers kept changing. That's okay, right?
Let me see.
The answer's 0.128, right?
So yeah, so that's just because you used it this way.
I think
And I just did it when I did the test
Like a
test
stat?
statistic, and it's just because
Test.
of the method you're
That's
using,
right,
whether you
that's
use
right.
that one or this one,
Go
but
there,
only
go there,
just
sorry.
like 3 digits.
And then go to
That's
the test.
split,
And
yeah.
that gives you the test statistic, degrees of freedom, and the p-value.
Yeah, I would, yeah. Steps, okay. 1, okay, yeah. Simple things kind of get you, that's not simple, but to me, you
No,
don't get
I
it
get you.
correctly, I mean, that way.
Any other questions here? All right, let's start making our conclusions. So our p-value is 12.8%. Is that less than 5%, our significance level? No, it is not. So it is not statistically significant. So we
12.8, you said? 12.8?
Yeah, 12.8%.
do not reject the null. And do not support the alternative. And then lastly, our conclusion in the context of the problem. At the 5% significance level, the sample data do not support the claim that the distribution of responses is not the same for each gender. Any questions? All right, we got one more.
You gave us the answer. No.
Ah, I did. Pretend that's not there. You don't see it. Okay, so a manager would like to determine if there are significant differences in the mean sales among 4 stores. The following table shows the sales in thousands of dollars tracked over 5 days. Test her claim using a significance level of 5%. Once again, you guys get a 5-minute head start. Be very careful in determining your lists. Please be very careful in determining your list.
Follow through.
Is this with L1 and L2 and so on?
It is, but what direction are we entering in? Our L1, our L2, our L3?
To the right.
Yeah, horizontally.
Wait, it's not gonna go down?
It's not in this example,
Right.
because what's the question asking about? The mean sales among 4 stores. We just happen to get the data across 5 days, but we're not comparing the data across days, number of days. We're comparing the data among the 4 stores.
It'll be
So
chi
that's
square for
L1,
independence.
L2, L3, L4.
Chi square for independence, no?
Mm-mm.
No.
So which one, there's only one case
Quantitative then, ANOVA?
in which we have quantitative data,
Yeah.
which is here,
ANOVA.
which is ANOVA, right? This is quantitative data, so it has to be ANOVA. Because we're dealing about money, the amount of money. All right, so let me pause the recording. All right, guys, so we had already discussed that this is an ANOVA problem. And so for ANOVA problem, the null hypothesis is always that the means are equal. We have 4 of them. So it's going to be mu1 equals mu2 equals mu3 equals mu4. And then for the alternative, at least one of the, what were we talking about? The mean sales, right? At least one of the mean sales is different, all right? That's what each of the means represent. We're starting off with our null, saying that the mean sales are all equal across the 4 stores. And our alternative is that we're saying at least one of the mean sales at one of the stores is different. Yes.
So at least I put at least one sales mean in thousands of dollars is different.
Yep. Perfect.
Yeah, oh.
All right. So now it even tells you to use ANOVA on your calculator to find the test statistic F and the p-value. So all calculator. So you do stat, edit, clear out any old lists you may have there. It's not letting me clear it. This app doesn't work very well sometimes. I think I froze it. Come on. There we go. Okay. So into list 1, I'm going to do the Alhambra store, which is 10, 15, 10, 20, and 20. For list 2, we'll do Burbank, which is 20, 20, 25, 15, and 20. For list 3, we're doing the Cerritos store, 3, 7, 5, 10, and 4. And then for list 4, the Downey store, which is 30, 25, 30, 35, and 30. So it just so happens that for each of our lists, each of these stores, we have the same sample size. It's 5 for each of them, right? Because we got the sales for each day. Did we have to have the same sample size?
No.
No. Good. So remember that. You could have them all the same. You could have them all different sample sizes. Either way is fine. Question?
Okay, for this problem, we would have made a mistake by putting each list downward, which is
Correct.
10, 23, 30. But this time, for this example, we read from left to right.
Just in
So
this
put it in-
example,
Just in this example?
it just happens to be that way. Yes,
So
because
if it was a different type of scenario, it could go
yeah,
from
they
top to
could.
bottom.
Yeah, they could have, instead of listing it out horizontally, they could have listed the store name on top. Alhambra, Burbank, Cerritos. They could have listed the store name on top with the info going down.
Oh, okay.
So it just depends. So in this case, though, what we're really comparing is the mean sales across all the stores. So we're comparing the stores, and that's how we enter in the value. Yeah, good question.
I had to clear out, the ones had wrong numbers in one from last time, but everything else is okay. Double check this. So 10, 20, 30. I'm sorry, 10, 23, and 30. 15, yeah. Okay.
All right. So does anyone recall how we get to ANOVA?
Stat and test.
Stat test.
And last one.
Yep, it's the last one, ANOVA. hit enter. So you do stat, test. I went up to ANOVA, hit enter. Now you have to tell it what lists you're doing, right? So we had 4 lists here that we entered into. So we're going to do second L1, comma. Do not forget your commas. Second L2, comma. Second L3, comma. Second L4, and then close the parentheses.
Got parentheses? Oh.
Hit enter. And it gives us a lot of info. But the only things I'm asking of you is for the F test statistic and for the p-value, both of which are listed there. So, for my F test statistic, we were given 35 point, and I'm going to go 3 decimal places, 0.295. Now the p-value, it's just an ugly value. The p-value, I got 2.7665, yada, yada, yada. And then E -7. Remind me, what does that E tell me? Good, we're gonna move it to the left 7 spaces. So that's the same thing as point 1, 2, 3, 4, 5, 6, 7, 8. So this is the same thing.
Make sure I get this in properly.
If I were to round this to 3 decimal places, this might as well just be what?
0.
0. Good.
Oh, not 1. Not 0.2, right? 0.02.
No, just this rounded 3 decimal places. Like looking at the first chunk, just 0.
Was it 4 lines or 5 lines? It's 5 categories, right? It's 4, right?
There are 4 stores. So list 1, list 2, list 3, list 4.
I'm counting 5.
Are you counting the stores?
So remember, don't
Are you
look.
counting the days with
Yeah.
this including?
No.
Yeah, don't include. So we're not counting the days, right? We're looking here along this column.
The days in five.
It's still 5. It's still 5 days.
No.
No, but we're comparing is not the days. We're comparing
Stores.
the stores. 1, 2, 3, 4.
Okay.
So this is why we only have list 1 through list 4 because we're comparing the stores.
Yeah, I gotta go back there.
Right?
Okay.
Yes.
That's why we're reading from,
Top to bottom.
Anthony.
I think we have 4 because when you put it in L1, L2, L3, L4, you read from left to right. L1, L2, L3, L4. Just don't even think about the thing.
Thank you so much. I just have a question though. I appreciate it.
Second element,
You have another question?
Yes, please.
Comma.
I mean, no, I got to do more because I did it. I have 5 lines
Comma.
before my list here.
Second
I put the
L3.
comma and we are ordered
So
with,
let's get
comma,
Yeah.
here.
second, L4,
Okay.
close.
Okay. So for the ANOVA, you do stat,
Test.
test, go right there, ANOVA, hit enter. See how it says ANOVA here?
Oh,
And then now this is where you enter L1. So you'll do second L1, comma, second L2, comma.
Okay.
Okay.
Thank you so much. Second of 3.
Okay. So now we could go to the conclusions. Our p-value, what percentage is that? 0%. What was our level of significance? 5, right? So it is, so that means it's statistically significant. So we reject the null and support the alternative. And then lastly, the conclusion in the context of the problem. At the 5% significance level, the sample data support the claim. And remember, your claim is the alternative hypothesis that at least one of the mean sales is different. All right, guys, don't forget, you do still have a full week. Okay, you have a full week from today before the exam. Study, study, study. Practice, practice, practice. Don't forget, Kristen will be here on Saturday as well before the exam.
Thank you so much. Appreciate it.
Practice. Yeah.
谢谢，谢谢。